Okay, so now we have a sum here which consists of beams and bars in different orientations, and we have to find the centroid, the center of gravity for this sum, this system here. The basic portion is a straight beam. We have three straight beams here. One is in horizontal direction, one is in vertical direction, and this one makes an angle of 60 degree with x-axis and 30 degree with y-axis. So we will solve this thing, and plus we have a semicircle here which is 20 millimeters away from the origin. This is the x and this is the y-axis. Here is our origin. So it is 20 millimeters away from the origin in x-axis and 60 millimeters above the origin for the y-axis. So all these things we will go through in this question. The first we will take is the portion AB. For AB, the total length of AB is 100 mm. If it was lying horizontal or vertical with respect to the origin and x and y axis, we would have directly taken 50, 50 as the coordinates of centroid, but it is making an angle 60 degree. So for x coordinate of this beam, we take 50, which is here, 50 cos of 60 degree, and the sum of this. We get an answer, suppose here by calculating we will get 25, but we need to understand that the x component, if we resolve this is the y component, this is the x component of the beam, the x component is directing towards the negative x-axis, so we take a minus sign here. Similarly, for the y coordinate, we take 50, the same angle would become sine of 60 degree. So we get a value of 43.3 mm. Here also is error. And this component is directing towards positive x-axis, so this will remain positive. The total length of the beam is 100 mm, as we saw earlier. So these three entries we will do in our table. This is the length, the x coordinate and the y coordinate. The multiplication of Li, that is the length and x coordinate, is here. The multiplication of again length and y coordinate is given here. Li yi and Li xi respectively. So this is the total calculation that we have to do for our first beam, that is first part AB. Next we will see BC. For BC, we can see B is lying on the origin and it is of length 20. So directly what we can see is, for the y coordinate of center of gravity for this BC would be 0. The y coordinate would be 0 because it is lying on the x axis, and the x, this will be 0, and the x coordinate would be half of the total length of the beam, which will be 10. So directly we can, and the total length is 20. So directly we can enter this, 20 is the length, 10 is the x coordinate and 0 is the y coordinate of this beam. So we get these readings by multiplication of the length and xi, we get Li xi. Since y coordinate is 0, the second product would be 0. So our second beam BC is also done. Now we'll look at the CD term. For CD is at 20 mm distance from origin in the for the x coordinate. So this will be G for this beam, 20 mm away, and it is vertically straight. So the x coordinate of CD would be 20. The y coordinate would be half of its length because its length is starting right from the x axis, so it will be half of the total length, which will be 30. The total length of the beam is 60 mm. So these entries will be made in the table as it is. 60 mm is the length, 20 and 30 are x and y coordinates respectively. We take the product of length and x coordinate, which is 1200, and length and y coordinate, which is 1800, and we fill in the tables. The next we have is the semicircular path. For the semicircular path, we can see that it is not associated with x or y axis directly. It starts at a distance of 20 mm away, and the center would be, if this centroid would be somewhere here. So this would be lying exactly on this vertical line, which is the straight, which will be perpendicular to the diameter here. And since the radius is 25 and this measurement would also be 25, this is also the radius of the diameter. So for the semicircular path DE, our x coordinate just from observation would be, x would be this 20 mm plus the other 25 mm of the radius that it has to cover. So we get the total x coordinate as 45 mm. For the y coordinate, the baseline, the diameter here, which is the diameter and also the, you can see that it is above the x-axis by 60 mm, and then once you reach to this level, you need to travel a distance d. So the y coordinate would be, first we have to travel this distance, which is 60 mm, plus a distance d, and this distance is given by 2r upon pi, where r is the radius, which is 25 mm. So once you substitute these values, you get the y coordinate as 75.93 mm. These two are the values. The total circumference of for this beam is also required. So that is L of the beam, and that is given as 2 pi r is the circumference of the circle. Since we are taking a semicircle, it will just be pi r. So once we put the value of r as 25 mm, we get 78.54 mm as the length of this circular bar. These entries are made in the table. This is the length, this is the x coordinate and y coordinate. We take the product of length and x coordinate, we get LIXI, and product of length and y coordinate give us the LIYI. So all these things are done. We take the summation of all these lengths, we get summation of Li. We take the summation of LIXI and LIYI, and our entire table entry is done here. So all the parameters are filled in. This was quite simple as compared to the laminar calculation that we have done. All we need to do now is to find the x and y coordinate of the entire system for the center of gravity. For the x coordinate of centroid, the capital X here is given by summation of Li xi upon summation of Li, and for the y coordinate, it is summation of Li yi upon summation of Li. So once we put in the values from this table, we get the x coordinate as 9.62 mm, and when we put these values for the y coordinate, we get the value as 46.77 mm. So this is the total entry done. If we are asked to locate the centroid, we need to move 9 mm, 9.62 mm towards the right, because since the values are positive here, we'll move towards the positive x-axis. So it will be, if this is 20, half will be 10 somewhere here, and 46.77 mm above. So this is 60, 46 would be somewhere. So at this junction G, capital G, we will find the center of gravity for our entire system.